Well, that's sad. Hey guys, no Coffee McQuaid here. And in this quick video, to complement the other ones that we're doing on the neural pathway, I'm going to be looking at the action potential. So, in regards to neural pathway, we know that we have the different systems, different types of nerves, and a nerve cell itself. But the action potential is the signal that is sent through the nerve. Because you know that nerves are pretty much like electricity, kind of wires that run through our body. And in this one here, we're going to be explaining why there is a positively charged or negatively charged signal going through our body, even though we're not plugged into power and all that kind of stuff. Because obviously that would kill us. Alright? So I'm going to quickly do a drawing on the board. Hopefully speed it up, or I'll just jump to when it's done, depending on how long it takes. And I'll catch you back when it's done. And we're back. Cool. Didn't turn out as well as I wanted. It's kind of a mess, but I'm going to do my best to try and explain it as far as the action potential. Maybe I might just tell you guys to look at a YouTube video. I might just be like, ooh, look at this YouTube video if I know how to edit, or I'll put it underneath. Anyway, so on the top here, we have outside the nerve cell, or the extracellular space. And on the inside here, we've got, on the bottom, we've got the inside a nerve cell. So that's within the dendrite, within the cell body, within the axon, within the terminal. Alright, so up the top and down the bottom in the red, I've got the relative charge. So outside the cell is positive, and inside the cell is negative. But if you have a look, there's a lot of potassium inside the cell, which has a positive charge. And you're like, but if there's only positive stuff, how does it have a negative charge, sir? This doesn't make sense, and I know maths. Yeah, I'm sure you do, Waddles, but not really. So, just blatant lie, but okay. It's because outside here, the charge is a larger positive charge. So in relation, this is a negative charge in relation to this one, because this has a larger positive charge, so as a result we call this one a negative. Alright, so this is it. Just normally the nerves there isn't any sort of signaling going on. It's having a snooze. This is what it does. Alright, so the next thing comes along, and there's a signal from another nerve or from the brain that comes along, and what happens is we have these channels here. They're called the sodium potassium pump. If you want to research it, you're more than welcome to. And essentially, this allows the sodium to flood across into the nerve cell. Now, because this is positive and this is negative, it's going down its concentration gradient, which is exactly what it wants to do. Alright? So, as a result, as this opens up because of the signal from the other nerve, this opens up and sodium floods through, changing it from a positive charge to a negative charge. Why is it becoming a negative charge? Because there is more positivity. Yeah, positivity is moving down inside the cell. So this is happening in just a section. Now what this does is this opens up and it causes the other gates along the nerve to open up as well. So it's almost like a Mexican wave. One starts to open up, and then it goes all the way through, flooding the sodium in, and inside the cell, you have this positive charge that is charging down, charging, probably not a great word for positive charge, but it's moving down the nerve cell, in through the cell body, down the axon. Alright? So it keeps on going, and then it gets to the terminal, and we'll find out what it does there in the next video. But if we focus on a single section, like just the little part, essentially what happens is this floods along, which then results in the next little gate opening. But this now means in the original section, you've got a highly positive charge on the inside and a negative charge on the outside. And for then a nerve to work, we need to get back to this original state. So if we go from here, now this same pump then opens up and then allows both the potassium and the sodium to go back in. Alright? But then if we end up like that, we're going to have all of it on this side. What happens is the potassium then goes back across to reach equilibrium or reach homeostasis, and then we go all the way back to here, and then that little section of the nerve is now ready to trigger another action potential. So this occurs every single time that a nerve is active. So if you think about trying to close your hands as quickly as you can, your nerve cells are telling your hands to close, open, as fast as you can. This is happening at that speed. It is flooding through, resetting, flooding through, resetting, flooding through, resetting. So that's how quickly it happens. So hopefully this helped. Maybe not, I'm not sure. Hopefully I didn't make you more confused. If you did, forget everything and have a look at the YouTube video that I'll probably link in down below underneath this one. Will say brackets actual action potential or something. I'll think of something, I'll forget what I've said here. Alright? But hopefully it helped, and I'll see you in the next one.